Good morning. With what we have learned so far, that is about the water pollutants and the typical BOD modeling. Then it's about this groundwater modeling and groundwater pollution. One very important thing, by now we have seen that there are many ways water can get polluted, either in the surface or in the groundwater. And now it's our turn to learn about the treatment of wastewater. Wastewater treatment becomes a very important area of environmental engineering. We will see in these classes, about 6-7 classes that I would take on this. You will try to understand. You will understand how this wastewater treatment is designed, what are the priorities, what are the typical methods that we generally follow in wastewater treatment. Having to say that, let us bring out the stages, the parameters of interest for wastewater treatment. See this. This is parameter unit operations. Unit operations in wastewater treatment. Right. The unit operations to start is any kind of, whenever we are discussing with water, anything requiring water, you also would understand that there would be a flow. There would be always flow. And the measurement of flow is a very important part. This is remaining is the measurements, flow measurements, who are to try to do. Most of the things that we would know, try to find out is flow rate, flow mix. What are the material that we have in the flow mixture? What would be the material that is important for this flow mixture, flow mix? Then we should have this about the flow, other things about the flow pH. All these aspects has to be seen in great detail. This is what is etc. Would see this. These are the flow measurements. That is the start with. Any kind of wastewater treatment method begins with the measurements. What are these? Then finally, there's a reaction time. What are the reaction times? Generally, for this reaction, residence time. Residence time is the time when a pollutant or a reactant would remain within the container. There's a total time that is required. Residence time, reaction time, then other rates, the flocculation rates, all this, the flow measurements becoming measurements. All this, where we have said those things, but here itself, as you can see that in terms of liter per minute or liter per second, flow mix, what would be the solid, liquid, gaseous phases inside the flow pH, all these things comes to be very important. These are the flow unit operations that we generally start with. The second one, another very important part is this, is the screening. Screening is one important part in wastewater treatment, where we generally try to separate out the immiscibles, those which cannot be mixed with the water. There will be something, and as you can know, says there are to be understood in this fashion. One is which is not at all dissolvable in water. There are many things like which that they are not dissolvable in water at all, and there are few things which are dissolvable, but as such anything which is dissolvable in water is also dissolvable to a saturation limit. So till that saturation point it would remain dissolved. Above than that, more than that, it will not be dissolved state. So just like if you continue to mix salt in water, the salt would be dissolve till a certain point, that is the saturation at that temperature pressure in water. Okay. So, as after that the salt would come out of the solution. Salt would be generally either remain deposited at the end of the glass or would remain suspended, as the case may be. So, this is what is this is separating out the immiscibles. The screening is a very important part of, I will also talk about, I will give you a flow diagram where you will be able to understand this, but these are the unit operations that we generally try to do or carry out. Comminution. Comminution. The word comminution you must have come across in blasting. Say the blasting is what is basically comminution means size reduction. Size reduction, say by different methods, by shredding, by crushing, by shredding, and by etc. Different means that we generally, meals are another, milling, crushing, etc. So, you can see this combination in the size reduction by shredding and materials like that. It has a great importance. As such, what is the importance of combination? Mostly, in one great important part of combination is that as soon as you break something, the surface area increases. The surface area has a great role to play. The surface area is, it increases the rate of reaction. It exposes more area available for reactions. So, this combination essentially does that. So, this is what is very important part. There are many cases when if you just shred it, a substance, say something like a bag, a leather bag in water. If you just keep it like that, and if you just shred it, completely cut into pieces and then put in the water, the biodegradation time of the shredded parts would be taking lesser time than the larger one. As simple as that, because the largest surface area of exposure. So, this is combination. This is combination is a very important part. This is the next is the flow equalization. Flow equalization. This is flow equalization is that is about equilibrium seeking parameters. Equilibrium seeking parameters. Say flow equalization would be something like wherever that the control of flow rate and control of flow rate in comparison to control of flow rate in comparison to say sedimentation rate, in comparison to control of flow rate in sedimentary rate. Then other designed parameters, combining equilibrium seeking parameters with the design. Say if you are is a very important part of experimentation. In an experimental part, wherever you are trying to design or experiment with something, one very important thing is that you must design for a perfect, say, a type of flow rate, a time that would be associated with the different reactants should be in contact with each other. Then you have to the flow rate has to be matched. Then you have to be the flocculates or whatever would be deposited, the removal of that at a particular periodic intervals. These times, the intervals, when actually how much time it takes, the measurement of that, and to form an equilibrium, so that whatever is the input and output are balanced. It should not be nothing like that. You are putting more input, you are not getting that amount of output. So there will be a process somewhere, process getting stuck somewhere. So this kind of situation is when we are trying to balance this kinds of situation, we generally talk about flow equilibration. So this whole flow equalization, that is what we generally talk about. This flow equalization or something that are called equilibration is another term where there is the equilibriums are sought. Process equilibrium. Equilibrium is input and output are matched. This is what is the condition of equilibrium. In situation like, as you know, in a perfect situation, in a different types of reaction in the water environment, say if you are choosing for a particular reactions to take place, say at a particular pH, certain deposition has to take place, you are aiming at that. So equilibrium would be at that pH, what would be the rate of flow, so that the equilibrium is reached. So the input and the output, there is a proper matching. This is what is important. In most of any kind of flow kind of situation, this particular parameter is of great importance. So there is another important aspect which you should also deal with, is that is mixing. So the mixing is mostly the mixing of the reactants. Mixing of the reactants. This is also of great importance, in the sense that in many cases in a design there is a risk, always there is a risk in the flow, that you would not be getting the designed rate of output. Say the reaction mixing is something like, say if you are sending these are the typical things that take place. Say if you are using lime in the water. So in such cases, when you are using lime in the water, or if you are adding alum in water, what happens is, if the water has a relatively high velocity, so the alum and the water would not come and mix. The alum would not find enough opportunity to meet with the reactants so say the lime would not find enough opportunity to meet with the reactants that it is designed to react with. Is that clear? So this kind of situation takes place. The mixing of the reactants is a very important part, so that the larger part of the body of water, say if you are mixing tank, in a situation like this, you will find that a top column is not being mixed, the bottom column is only getting mixed. So that would, how to make a homogeneous mix in the total column. This is what is the mixing parameters. These are the situations where we would like to know more about the mixing. So here is the mixing of the reactants, mixing of the chemicals, reactants, chemicals, gases, etc. Which are maintaining and maintaining the solids in suspension. Maintaining solids in suspension. This is what is the mixing part. Flocculation is one great important this is a flocculation to promote agglomeration of the small particles, agglomeration of the small particles. Have you ever seen, you would understand this agglomeration. The process of agglomeration is the use of alum in water. Have you ever seen how this alum reacts in water? Next time if you go, go home or anywhere, try to see what alum does. Just pick a small piece of alum, drop it into a pitcher, or in a container full of raw water, and just see what it does. You just leave it for some time. Yeah, it would clot the all particles. What it is actually doing is agglomerating the particles. So one aspect of alum use is agglomerating small particles together. So what happens is, as a result of that, the mass actually increases. So as soon as the mass increases, it would be, once it gets agglomerated, the mass itself, as the density increases, so as a result of which it begins to settle or remains suspended at one point, and so that they are also visible. At that way, they become visible also. Even as small particles in solution, they may not be visible, but when they are agglomerating, it becomes more visible. You come to know what are the parts to be removed. So this is what is agglomeration of flocculation. This flocculants or the flocculation is a great important part of wastewater engineering. Sedimentation. Say one or sedimentation. The sedimentation is the removal of settled particles, settled solids, and thickening. Sedimentation, removal of settled solids and thickening. So you have to, first of all, after you have flocculate, you have done the flocculation, but if it remains suspended in the body of the water, like if you see in a pump or in a container like this, you would expect that these particles, these flocculants, after the flocculants have generated, you would find the particles suspended like this. Irrespective of this, in a sedimentation process, you would generally try to see that this particular, in the body of this water, these particulates settle at the bottom, so that it becomes easier for you to remove them. It becomes time to time, periodically, you can remove the settled particles, and this is the place where agglomeration is taking place. This is the flocculation. Either by the flocculated product, this is what is sedimentation. So here you can see that the difference. These are sedimentation. This is what is desirable. In a plant, we would try to have, say, the material being sedimented, because only then, when they are sedimented, it is easier for us to remove them. It is important for us to have a situation where we can remove the material. The next is the flotation is another this froth flotation and the selective. This is a selective agglomeration of selective agglomeration of finely divided substances, and substances of a particular type. Selective agglomeration of finely divided substances of particular type. If you remember, this flotation is what happens in the flotation chamber. It doesn't matter whether it would, in a flotation chamber, in all cases it would generally try to attach something, some of the particles, selected particles, like if you remember this, if you in a mining processes, very common in mining and concentration process, froth flotation. What we generally do in the froth flotation, we generally use a particular, say, organic or metal organic substance, say sodium xanthate or potassium xanthate that we use. This sodium xanthate and potassium xanthate, particularly in a copper concentration process, it would only agglomerate with the copper particles and bring it up in the surface. bring it up in the surface. This is the flotation part. So, here it would be another very important part is selective agglomeration, because you do not require to take everything up. You would only try to take a very typical particle that you want to bring that up and want to remove them for different purposes. In froth flotation in copper, this particular maybe this particular substances, it may be due to say the removal of dirt or collection of a particular element, say enriching copper, or this kind of things, we would use that froth flotation. So, here also you can see the flotation is being also very important part. Filtration is another. Filtration, where it is the fine filtration is the removal of fine residual of finely divided residual material. Removal of finely divided residual material. This is what is the procedure of filtration. We have to filter out. Also, we have seen mostly. So, you won't like that in the flocculated material or the sedimented material to remain in the flow. You would have to separate them out, and how to do that? This is one is the filtration is one method by which we do not generally do it. There is another aspect, this today is this is filtration and microfiltration or micro screening. Micro screening, say example is removal of algae. Removal of algae or any other substances, algae kind of mostly the algae and say fungus also, etc. If they are present, if any. So, this is about micro screening. Gas transfer, there would be during the process of reactants, there would be a number of gases would be produced, gases like nitrogen, the gases like carbon dioxide. Say this particularly, then this several organic VOCs, a large quantity of VOCs are produced, H2S is produced. So, this you can see, this needs to be this gas transfer, this gas to be generally has to be removed. Sometimes it has to be added or removed. Addition is also required. This is the gas transfer. Sometime the gas transfer, this addition is required just to initiate a certain reaction. Gas transfer may be needed. So, otherwise, in a chamber, if you just see, we will try to see, say activated sludge process or any other process, you will see you will produce lot of gases also. That gases also have to be removed time to time. Periodically, that has to be removed. So, otherwise, this can be of dangerous consequences. The gases can do. So particularly if it is a closed process, if there is a huge build up of gas, it can be extremely dangerous also. So, time to time the gas has to be removed, the degassing or this gas transfer is taking place. This another is volatilization and gas striping. Volatilization and gas striping. You see here, you can see there will be there are some substances like some substances which at particular temperature pressure would be volatile. Generally in STP, mostly we know standard temperature pressure, we know those substances which are kept out in the open, they would remain, they would volatile, they would be vaporize, but there would be some situation where if you increase the temperature, a substance from either from the liquid or from the solid may go into a gaseous phase. that is also the volatilization and gas trapping. Gas trapping is taking place particularly with the use of, say, volatilization, as you say, is, as I have said, at a different temperature and pressure, at different temperature and pressure, certain substances will go out, certain substances will go out of the solution, will go out of the solution in the form of vapor from the initial solid or liquid form. The form of vapor from the initial solid or liquid form, say the liquid form. So, you can see this solid and liquid form is a camphor. As you know, camphor as a substance, if you heat camphor, it does not go into a liquid phase, it immediately goes into a vapor phase. So, it is something like that. There will be many substances, the liquid, say liquefied nitrogen gas, liquefied oxygen, whenever they are released in the standard temperature pressure, they become volatile. So, these are the gas trapping is also taking place. Here is a gas trapping is a case where particularly a number of say there are substances like say granulated activated carbon, GAC we call them, the granulated activated carbon. This granulated activated carbon, this is called granulated activated carbon. Granulated activated carbon. What is this aspect of this granulated activated carbon? Basically the difference, if you just see coal and it is basically coal and coke that we see, the coking, the process of coking by which the coke is produced. What is the difference? The essential basic difference is the number of surface areas are more. The surface area is more, not number, total surface area is more. Suppose if there is a substance like this, if say there is a substance like this has a regular surface, very very plain, very smooth surface like this. But on the other hand, if this surface can be made to be like this, where you are increasing the surface area, and as a result of that, particularly when you are increasing here and here, you see this is the granulated part, this is a granulated and activated. We call it this activated because these surfaces are very good to keep the gas absorbed in those openings or in those holes or opening that they create. So, it is across the body. That is the difference between coal and charcoal. What you see in a coal and a charcoal is basically the coal would be having lesser surface area. For the same mass, the coal would have a lesser surface area than charcoal, or for that matter coke also. As a result of what happens is, as this surface area increases, within this surface area, number of gases can be absorbed. Like one of these, is one of the areas, most of this water that you can see, in your water filtration plants that you see in your hostels or anywhere, there is one chamber which is basically full of granulated activated carbon. It's most basically charcoal, treated and sized charcoal. It's not a large size charcoal. As the size increases, the surface area further increases. So, the size charcoal, this charcoal is through which the water is generally passed. What happens is the bad odor, the odor that we generally have in a bad smell in the water, that can be removed. So, even after treatment, the water might contain some of the say the substances which are which can generate bad odor. or say bad smells. So these odors can be, the odorous gases can be absorbed by these activated carbon surfaces. This is what is the volatilization and gas trapping. We generally use this gas trapping in various industrial wastewater treatment methods. Okay.
Charcoal is also used in that Eureka phosphate.
Right. Yes. Yes. So this is the charcoal. The use is the granulated activated. The only difference is the surface area is not saturated. The surface area is in a highly exposed surface area, and this surface area under a particular pressure, under a pressure condition, can absorb a number of gases, mostly the odorous gases, as a result of which the water becomes much more acceptable. Okay, the water will be much more acceptable as such. So, this is what is required for the gas trapping. So, these are the processes that we generally deal, the processes and parameters that we deal in wastewater engineering. So, okay, having gone from this, let us try to see how this, what are the methods of wastewater engineering that we generally, the typical classification methods and the typical process that we generally observe. Here you can see this. Now it is that in many cases like this, if you just see wastewater influent, let us make a process first. Wastewater influent, this is why water is getting inside into the system. The screens, there would be screens, and this is screens and comminution. This is where they would be screened. They would be screened and they would be laid by a process like this. This is screening and comminution. We will find a grate chamber. Then we will find a grit chamber. Grit chamber. This, in the grit chamber, we generally try to separate out this, most of the foul materials. So I will come back to this. Grit chamber. After the grit chamber, you find that is we generally call this as a primary settling. Primary settling. In the process of this primary settling, we can find out this primary settling. We will see this here. We'll use a loop here. Let me come back to that later on. So this is what is called the aeration process, aeration tank. This is aeration. Then comes the secondary settling. Primary settling we have seen. Then we see secondary settling. We have secondary settling. After the secondary settling, we generally use, after this, if you just see this secondary settling now, this secondary settling here continued, say A, here A continued. So you here can see this secondary settling. We generally use chlorine. Chlorine is a chlorinated substance. Chlorine can be used, any kind of chlorine in the form of bleaching powder or whatever you generally use. We can use alum, we can use say lime, all these substances that can be used here. Then this is what they would be added here, chlorine contact here. This is this contact basin. This chlorine here is a contact basin. In this chlorine or whatever we generally try to do, this should be actually say the drawing would be somewhat like this. This is, you just correct this drawing, this is like this. Okay, I think I made a mistake here. So, you say this is a mixing chamber. This is to say there is a mix in a mixing chamber. Mixing chamber. Then we go for mixing chamber. This is what is the primary settling. Then the mixing chamber. Then it will go for the secondary. This is primary. This is primary settling. Aeration, secondary settling. After this is this is called, okay, this is called, then we go for tertiary treatment. Then we go for tertiary treatment. So, here this is called the tertiary treatment. So, you can see this, this is the process. Let me explain you first. What is happening here is wastewater. With this wastewater, remember, a standard wastewater, I mean any water that is coming from different sources, water coming from different sources to the plant. What we expect, what we get in the water, say water is basically high turbidity, high BOD, it might, or high BOD, high COD, or high TDS, high TSS, all that will have. So, this depend upon the characterization of the water. What are the water has, what are the things the water has. If it is a particularly say sewage wastewater, you may not, you will find mostly the high BOD and high COD. As I have said, in mostly say oxygen, another very important thing is oxygen deficiency. Oxygen deficiency. This should be deficient in oxygen. Mostly all this wastewater would be deficient in oxygen. Apart from that, there will be some gang materials. They say this we generally called tramps. These tramps are say a shoe, a number of shoes, then say this iron pipes, then you will find say plastic is another very important thing, plastics. So, you can find this is what is in the influent, if you just see the character of the influent. So, what we do in the screening, in the part of the screening and combination, if in the part of the screening and combination, what we are trying to do is we are just trying to separate out in the screens itself, screens, and wherever required you are breaking them, so that in a large part of that in small pieces it passes to the screen. Okay. So, you can see this so in the screen also, in the screen whatever is available in the screen, whatever is the excess size, the plus size that you can see, the plus from the screen would go through a combination process, and would be again referred back to the stream. It would be again referred back to the stream of water. Okay. So, this can be seen like this, but this what we do with the iron pipes or plastics or things like that, all iron pipes they would be broken? No, they would be just separated out, they would be just taken out. There would be some other implements by which this material would be taken out from the body of the water. So, here you see the water that we generally observe here is itself, we are just trying to find out here is if this is the flow is like this, a flow is a high velocity flow, this high velocity flow going through the screens, and finally when it is coming to a grid chamber in the form of a grid chamber, it would be this generally large and wide. The reason being is, as a result of which the kinetic energy of the water, would be converted into potential energy. As the potential energy increases, the velocity decreases. So the velocity decreases means settling increases. Essentially, we have to settle those things. Particles we have to settle. When they are in a flowing in a particular above the critical velocity, they would remain in the suspension. So as soon as you reduce the velocity, what would happen? They would begin to settle down. So this is what is the grid chamber. So in the grid chamber, whatever has passed through the screens would be first allowed to settle. And this settled in the grid chamber. So in a grid chamber, if you just observe a grid chamber, a typical grid chamber, if it is an open grid chamber, it would be like this, where you can find out, say this one is, here you would find out in an open grid chamber like this, where a large part of this would be in a grid chamber. What would be happening is, so this is how the water is being passed, this is the level to be maintained. As you can see, this water coming down, so here the level is maintained. So here the particles which would be settling here, the particles that would be settling here would be taken out. Okay. So the settled, you try to understand this. This is what is coming from the screen, with lot of TSS, TDS. It also has TDS. You cannot do much at this level. What you are trying to handle this at this time is TSS, the more total suspended solid, all kind of suspended material. This suspended material, as this velocity reduces, so you can find a large body of particles, large body of material would begin to settle at the bottom, isn't it? Would settle at the bottom. As they settle at the bottom, the water would be more clarified on the top. Water would be much more clear on the top, and this water would then be taken out. Okay. See, till this time we have not seen any kind of reactants being added to the water. We have not added anything so far. We are just trying to physically remove things from the water. So this is also, there would be followed by a grid chamber. There may be another primary settling tank where even smaller particles would be allowed to settle. Okay, even smaller particles would be able to settle. Then we would add, this is what is the aeration. Then the next stage is aeration. What we do in aeration? The aeration has a great importance. Let me explain a little bit about aeration here. This aeration has a great role to play. In most cases, all this kind of reactions, if this particularly this in the oxygen depleted water, this can result due to very high TDS and very high BOD, right? In both the cases, the water may be substantially depleted. Okay, you remember that plot I have shown you, that that increased salinity, the oxygen concentration decreases. So this is what is the increased concentration, increased dissolved concentration of equivalent salinity would actually reduce the oxygen in water, the level of oxygen in water. Oxygen also be reduced by this BOD also, biochemical oxygen demand, the oxygen that would be used for decomposition of the substances. So this oxygen depleted water would be aerated. What would be done? They would be the starred. They would be the typical methods of aeration is typical method of aeration where would be, say, the mixing. This is one of them is a starring operation that we generally do, the starring, a large bit of starring that we do. Say the surface aeration also can take place. We generally allow it to come in contact with the air around it. So as a result of this is here it is. How it helps? It helps significantly. it helps significantly because it increases the rate of biochemical decomposition. It increases the rate of biochemical decomposition. It also increases the reaction rate because many reactions in water would require it increases the reaction rate because many reactions would require oxygen as one of the reactants. As reactions would require oxygen as one of the reactants. I will show you some example where you would find that the oxygen is a necessary part not only for biochemical degradation, but it is also required for chemical precipitation purposes. Where oxygen is required, oxygen has to be added. So this addition actually helps that. The next part is the secondary settling. After this after this one is added, there is maybe another secondary settling chamber. A secondary settling chamber in such cases would be here, where there would be again another settling would take place. Till this part we generally known as till this time is known as primary treatment. So till this time the secondary treatment, secondary settling, we generally talk this as the primary wastewater treatment. Primary wastewater treatment, that is, say, from the screens to secondary settling. In many cases, even in places like very many places, like even in places like IIT Kharagpur also, even the typical wastewater treatment method, if they are not using any substances at the treatment method, so basically till this much, only primary wastewater treatment. What we are generally trying to do is, most of the cases we are not adding anything, we are just allowing the natural reactions to take place. We are trying to facilitate the natural reactions, the substances that are within the water, that they are reacting with each other and finally settling. So this is what is called the primary wastewater treatment. Then comes the secondary wastewater treatment. Where we are adding something. Here you can see this in the last part, as you can observe here, and I have said here that this one where is the chlorine is being added, chlorine, alum or lime being added with the water. This is what is called the the secondary treatment. This is the start of the secondary treatment in water. Now what happens here is that much of this part here, if you can observe now, this secondary wastewater helps reduce, the idea is to reduce, helps reduce what? Helps reduce mostly the TDS. It generally the TDS, mostly say the fixation of the sulfates, then carbonates, bicarbonates, and say the sulfides. You can think of all kind of substances, the radicals that are possible. So in here we are just trying to address to the situation where we would try to bring down the concentration of these substances, or either in the form of a radical or in the form of a element. Okay. So, here this is what is generally we are trying to see here. In the final part here at this in the method of treatment here is the tertiary treatment. Tertiary treatment. The tertiary treatment target primary tertiary treatment target a particular tertiary treatment target a particular element, say a trace element, which may not be removed by this secondary primary and secondary wastewater treatment. This can only be removed by maybe using a tertiary treatment method. So, bulk material, bulk pollutants in water, say iron, zinc, mostly iron, zinc, say sometimes even say a copper, then say say something like copper, aluminum, all these bulk substances would be removed from the wastewater stream by the secondary wastewater treatment. But for tertiary treatment, suppose we are targeting a particular pollutant in water, say mercury, say chromium, say cadmium, or say even say arsenic. Whenever we are trying to do that, we have to adopt a specialized technique, which would be added at the end of this tertiary treatment, at the end of the method. But this, as you can see, this tertiary treatment methods are expensive, and so most of the wastewater treatment stops at the secondary wastewater treatment. In our country, whatever you are seeing that wastewater treatment is taking place, most of the wastewater treatment stops at the secondary wastewater treatment method. The tertiary treatment method is being expensive and being being generally much more difficult to control. So, as a result of which, most of the people, generally most of the places, the governments also would not do the tertiary treatment. But the case is, it is much more necessary nowadays. It is much more necessary nowadays because we are finding a number of pollutants in water which are so resistive to the standard treatments like say primary and secondary wastewater treatment, that they can only be treated in the tertiary wastewater treatment method. So, otherwise this can be, say, in the trace elements, say then the organics, pesticides, very right, pesticides, all these require tertiary treatment. They cannot be removed by this primary and secondary wastewater treatment up to a below the threshold. So, this is what is all important. All right, I am coming back to this class again. This for this class, this till this time, this part is completed. Okay.